Okay, so I know yesterday's video was very long. Today is much shorter. We're actually, I call these timed-out lessons. They're little lessons that go over topics that, that you need to know for the next lesson, but doesn't necessarily flow with the curriculum. So when I was looking over the next lesson, I realized that there was a concept in there that you have never seen before, or if you have, it's been a while. You might have seen this, but it would have probably not been taught extensively. So I do want to make sure that we have this. So we're going to call this a mini lesson. Maybe we'll do an activity with it tomorrow. So this right here may not seem to flow from binomial expansions, but you will use it in the binomial theorem. So make sure that you understand this, because if you don't understand this binomial theorem, it's going to be a disaster. So we're going to talk about something called a combination. This is actually a probability and statistics concept, okay, combination. And what it does is it takes the idea of, let's say that I have 25 kids in a class, all right, and I want to put them in groups of 4, and I want to know how many possible groups of 4 I could make with 25 kids, all right? So I would have to give each kid, maybe number 1, number 2, number 3, number 4, right? And then I would have to put them in groups. I would have 1, 2, 3, 4. Okay, 1, 3, 4, 5, 2, 4, 5, 6, up to, this is really not a pattern, but I would have 22, 23, 24, and 25. Okay, but 25 can be in a bunch of different groups. So can you notice how many different possibilities we could get here? Yeah, I would be sitting for hours trying to figure that out. So thankfully, there is formula and calculators. So I'm going to show you both calculators. Almost all of your calculators should have this button. I'm going to cover the Casios and the graphing calculators with you today, where the button is, because there's a nice little button that will take this. You put the number 25 in, you put the number 4 in, and it will spit out the combination, which is good, because that's what we actually need for the binomial theorem. So let's just talk about the formula really quick so that we can, so we're familiar with what it's doing. So notation, first of all. Okay, so if I have 25 and I want to choose groups of 4, all right, the notation for that is actually going to look like this. It's 25, big C, 4, all right, and what this is N is the number of values that I have, C is the number of values I want to choose. So NCR, that's how it's always been written. So for the notation for combinations is NCR. And on your calculator, that's actually what the button will say. It will say NCR. Another notation that you will see, it will look like this. It will be parentheses with an N and then an R. There's no fraction bar, there's nothing. This means N choose R. So, and when we talk about binomial theorem tomorrow, it will use this notation, as N choose R. It will look like that. So I also want to talk about something else that I hope you've seen this before, but maybe you haven't. Okay, a factorial. Okay, factorials are used in combinations. All right, that's like N exclamation point. And what that means is if I were to have something like 5 exclamation point, it takes 5 and multiplies it by everything all the way down to 1. So 5 times 4 times 3 times 2 times 1. All right? So covered just a couple of new concepts with you. The idea of a combination, this is the way it looks. N choose R, okay? Or in the parenthesis N over R with no fraction bar but big parentheses on it, okay? A factorial, we take a value to an exclamation point, means I multiply that value by all of the terms less than it down to 1. So 5 factorial will be 5 times 4 times 3 times 2 times 1. Okay, these are counting principles. That's why we'll have no negatives, and 0 for the most part is not used. So let's look at a formula, combination. Okay, formula looks like this, n factorial. So if I were using my 25 C4, it's 25 factorial over n minus r, parenthesis factorial, times r factorial. So let's use that example again. It would be 25 factorial over 25 minus 4, which is 21 factorial, times 4 factorial. Now that's still going to take some time, okay? If I have to multiply 25 times 24 times 23, so forth all the way down, that's still going to take me quite a bit of time. Note that there are a lot of calculators that will have an exclamation sign on it. That actually means factorial. So I could put 25 factorial over 21 factorial times 4 factorial. But I want to show you one. I want to show you an easy way. Okay, calculators. 25, choose 4. All right, so in the graphing calculators, it is under math. So when you go to math, then you will scroll over to probability. It says something like PRB. Okay. Now on my calculator, it's number 3. It may not be that way on everybody's, but it will say something like this: NCR. Now again, this may not be the same. It may be in a different place, but it will be under the probability tab. So with NCR, I need to, so before I push the button though, I have to make sure I put 25, then I push the button, and you'll see a big C show up, then I put a 4, and it will give me the answer. And I actually did not calculate it using my calculator, so let me go grab that. So if I were doing my homework right now and I had something that was 25 to choose 4, I would type in 25 in my calculator, hit math, scroll over to probability, hit 3, and put in a 4. Okay, and I was wrong. On mine, it actually reads like this: 25 NCR. Then I hit 4, hit my equal sign, and it gave me the number 12,650. So if I wanted to take a class of 25 and figure out how many possibility groupings of 4 I have 12,650 possible groupings of 4 in a class of 25. That's a huge number. So let's just do a couple more examples, and then I will give you your homework. So let's try 10. I'm going to put it in this notation, because this is what we're going to see when we do binomial expansion, or binomial theorem. So I would type in my calculator 10, math, probability. Okay, we're just going to give me that NCR. And I'm going to choose 3. So if I had 10 people and I was trying to choose groups of 3, I would have 120 possibilities. We're going to do one more. 6, choose 2. I would have 6 NCR 2. 6 math probability 3, 2 is 15. Okay. One other thing, if you have a Casio, and I've checked a couple of Casio, so I don't know this for sure, but this NCR on the calculator is a shift divide, I think, on a lot of them that I've looked at. So the NCR is actually sitting above the division sign. So that will work too. But you do it the same way. You put the number in, then push the NCR, and then push however many you're choosing. So homework will probably be a worksheet tonight. So.